Our story begins over 4.5 billion years ago, in a time when the universe was still young and chaotic. Imagine, if you will, a vast cloud of gas and dust stretching across the cosmos, a nebula. This cloud was a remnant of ancient stars that had lived and died, scattering their elements into the void. This nebula, swirling and churning in the vastness of space, was a dynamic and ever-changing environment. Within it, particles of dust and gas collided and merged, driven by the forces of gravity and turbulence. Gradually, drawn together by an invisible force, gravity, the particles began to clump. These clumps grew larger and larger, forming planetesimals, the building blocks of planets. This was the birth of our solar system. Over millions of years, these planetesimals collided and merged, forming protoplanets. The solar system was a chaotic place, with countless collisions and impacts shaping the young planets. As the cloud contracted, it spun faster and faster, flattening into a disk. At the center of this disk, the pressure and temperature increased until nuclear fusion ignited, giving birth to our sun. At its center, a star ignited, our sun. The sun's intense radiation and solar winds began to clear away the remaining gas and dust, leaving behind the newly formed planets. Further out, the swirling dust and gas coalesced into planets. These young planets were still hot and molten, bombarded by asteroids and comets shaping their surfaces. One of these planets, a hot ball of molten rock, would eventually become our home, Earth. In its early days, Earth was a hostile and volatile place, with a surface covered in molten lava. For millions of years, Earth remained a hostile and unforgiving place. The surface was constantly reshaped by volcanic eruptions, earthquakes, and impacts from space debris. Volcanoes erupted, spewing lava and gases into the atmosphere. These eruptions released water vapor, carbon dioxide, and other gases, gradually forming a primitive atmosphere. The surface, a fiery, molten sea, offered no haven for life. Yet within this inhospitable environment, the building blocks of life were beginning to form. Yet within this chaos, the seeds of our planet's future were being sown. Over time, the Earth's surface began to cool, forming a solid crust. Water vapor condensed to form oceans, and the stage was set for the emergence of life. Slowly, over eons, the Earth began to cool. The molten surface solidified, forming the first crust. Water vapor, released from the cooling rocks, condensed in the atmosphere. Torrential rains fell upon the Earth, filling the first oceans. These oceans, teeming with dissolved minerals, would become the cradle of life. Within these primordial seas, something extraordinary happened. Simple organic molecules, the building blocks of life, began to assemble. These molecules, self-replicating and evolving, gave rise to the first single-celled organisms. Life, tenacious and adaptable, had gained a foothold on our planet. These early organisms, though primitive, possessed the spark of life that would eventually give rise to the incredible diversity of life we see today. The Paleozoic era was a time of dramatic change. Spanning from approximately 541 to 252 million years ago, this era witnessed some of the most significant evolutionary milestones in Earth's history. It was a period marked by the emergence and diversification of life forms, both in the oceans and on land. The Earth itself was undergoing dramatic transformations, with shifting continents, fluctuating climates, and evolving ecosystems. This era set the stage for the complex web of life we see today. Over millions of years, life in the oceans flourished. The seas teemed with a myriad of organisms, from simple single-celled creatures to more complex multicellular life forms. Coral reefs began to form, providing habitats for countless marine species. The oceans were a vibrant tapestry of life, with each organism playing a crucial role in the marine ecosystem. This underwater world was a hotbed of evolutionary experimentation, leading to the rise of new species and the extinction of others. Simple organisms evolved into more complex forms. Algae and other photosynthetic organisms played a pivotal role in producing oxygen, transforming the Earth's atmosphere, and paving the way for more advanced life forms. The Cambrian explosion, a pivotal event in the Paleozoic era, saw a rapid diversification of life with the emergence of many major groups of animals. This period was characterized by the development of hard body parts, such as shells and exoskeletons, which left behind a rich fossil record. Invertebrates like jellyfish and worms patrolled the seas. These simple creatures were among the earliest forms of animal life, and they played a crucial role in the marine food web. Jellyfish, with their gelatinous bodies and stinging tentacles, drifted through the water, capturing prey. Marine worms burrowed into the seabed, recycling nutrients and aerating the sediment. These invertebrates were the pioneers of the ocean, setting the stage for more complex life forms to evolve. Shells and evolutionary innovation provided protection for creatures like trilobites. Trilobites, with their segmented bodies and hard exoskeletons, were among the most successful and diverse groups of early animals. They scuttled along the ocean floor, feeding on detritus and small organisms. The development of shells and exoskeletons was a major evolutionary leap, offering protection from predators and environmental hazards. This adaptation allowed these creatures to thrive in a variety of marine environments. Then a pivotal moment occurred. Life emerged from the sea and onto the land. This transition was a monumental step in the history of life on Earth. The first land-dwelling organisms were likely simple plants and fungi, which colonized the barren landscapes and began to transform the soil. These early pioneers created the conditions necessary for more complex life forms to follow. The move from water to land required significant adaptations, including the development of structures to support the body and prevent desiccation. Plants, the pioneers of this new frontier, began to colonize the continents. Mosses and liverworts were among the first to take root, spreading across the land and creating the first terrestrial ecosystems. These early plants played a crucial role in stabilizing the soil and creating a hospitable environment for other organisms. As plants evolved, they developed new structures such as roots and vascular tissues, which allowed them to grow taller and spread further. The greening of the land was a transformative event, reshaping the Earth's surface and atmosphere. Their arrival transformed the barren landscape, paving the way for the evolution of land animals. The first animals to venture onto land were likely arthropods, such as millipedes and early insects. These creatures exploited the new habitats created by plants, feeding on decaying plant matter and other organic material. The colonization of land by plants and animals was a gradual process, driven by the need to escape predators, find new food sources, and exploit new ecological niches. The oceans too witnessed remarkable changes. As life on land began to flourish, the marine environment continued to evolve. New species of fish, mollusks, and other marine organisms emerged, adapting to the changing conditions. Coral reefs expanded, creating complex habitats that supported a diverse array of life. The interactions between marine and terrestrial ecosystems became increasingly interconnected, with nutrients and energy flowing between the two realms. Fish, with their streamlined bodies and powerful fins, became the dominant predators. These early fish were equipped with sharp teeth and strong jaws, allowing them to capture and consume a wide range of prey. The evolution of fish marked a significant shift in the marine food web as they became the top predators in the ocean. Some fish developed specialized adaptations such as armor plating and spines to protect themselves from other predators. The rise of fish set the stage for the eventual emergence of amphibians and other vertebrates. Some, like the Tiktaalik, developed primitive limbs, allowing them to venture onto land for brief periods. Tiktaalik is a key transitional fossil, bridging the gap between fish and tetrapods. Its limb-like fins and flexible neck allowed it to navigate both aquatic and terrestrial environments. This adaptation provided a significant advantage, enabling Tiktaalik to exploit new food sources and avoid aquatic predators. The evolution of limbs was a crucial step in the transition from water to land, leading to the rise of amphibians and eventually reptiles, birds, and mammals. These were the ancestors of all terrestrial vertebrates, including ourselves. The evolution of limbs and lungs allowed these early vertebrates to colonize a wide range of terrestrial habitats. Over time, they diversified into a multitude of forms, from amphibians to reptiles, and eventually mammals and birds. The legacy of these early pioneers is evident in the vast diversity of life we see on land today. Their journey from water to land was a remarkable evolutionary achievement, shaping the course of life on Earth. The Paleozoic era ended with a cataclysmic event, the Permian-Triassic extinction. This mass extinction event, also known as the Great Dying, was the most severe in Earth's history. It wiped out a staggering number of species, both in the oceans and on land. The causes of this extinction are still debated, but it is believed to have been triggered by a combination of factors, including massive volcanic eruptions, climate change, and possibly an asteroid impact. The aftermath of this event reshaped the course of evolution, paving the way for the rise of the dinosaurs in the Mesozoic era. Volcanic eruptions, climate change, and possibly an asteroid impact combined to create the most severe mass extinction in Earth's history. The volcanic activity released vast amounts of greenhouse gases, leading to global warming and ocean acidification. These environmental changes had devastating effects on marine and terrestrial ecosystems, causing widespread extinction. The impact of an asteroid would have further compounded these effects, creating a cascade of environmental disruptions. The Permian-Triassic extinction event marked the end of the Paleozoic era and set the stage for the next chapter in Earth's history. Over 90% of marine species and 70% of terrestrial species vanished. This mass extinction event had a profound impact on the course of evolution, wiping out many dominant groups of organisms and creating opportunities for new forms of life to emerge. The recovery from this extinction was slow, but it eventually led to the rise of the dinosaurs and the diversification of life in the Mesozoic era. The story of the Paleozoic era is a testament to the resilience and adaptability of life on Earth as it continually evolves and overcomes the challenges of a changing planet. From the ashes of the Permian extinction, a new era dawned, the Mesozoic. This period, often referred to as the Age of Reptiles, was a time of incredible transformation and diversification in the history of life on Earth. The Mesozoic era is divided into three distinct periods: the Triassic, Jurassic, and Cretaceous. Each of these periods saw the rise and fall of various species, but it was the dinosaurs that truly came to dominate the landscape. This era, spanning over 180 million years, is often called the Age of Reptiles. During this vast expanse of time, the Earth underwent significant changes. The climate was generally warmer, and there were no polar ice caps. This allowed for lush vegetation to thrive, providing ample food for the burgeoning dinosaur populations. Dinosaurs, a group of reptiles that had evolved during the Triassic, rose to dominance. The Triassic period was a time of recovery and rebuilding for life on Earth. Following the mass extinction at the end of the Permian, which wiped out nearly 90% of marine species and 70% of terrestrial vertebrates, the survivors began to diversify and fill new ecological niches. Early dinosaurs were relatively small and bipedal, but they quickly evolved into a wide variety of forms. They diversified into a bewildering array of shapes and sizes. From the small, agile coelophysis to the massive, long-necked sauropods, dinosaurs adapted to a range of environments and lifestyles. This incredible diversity is one of the reasons why dinosaurs were so successful and dominated the Earth for such a long period. Giant herbivores like Brachiosaurus and Stegosaurus grazed on lush vegetation. These massive creatures played a crucial role in their ecosystems, helping to shape the landscape by feeding on vast quantities of plant material. Their size offered protection from predators, and their long necks allowed them to reach high into the trees for food. Fearsome predators like Tyrannosaurus rex and Allosaurus stalked the land. These apex predators were at the top of the food chain, hunting other dinosaurs and keeping herbivore populations in check. Their powerful jaws and sharp teeth made them formidable hunters, capable of taking down even the largest prey. Pterosaurs, flying reptiles with wingspans exceeding 30 feet, soared through the skies. These remarkable creatures were the first vertebrates to achieve powered flight, and they occupied a variety of ecological niches. Some pterosaurs were fish-eaters, skimming the surface of the water with their long, slender jaws, while others may have hunted small terrestrial animals or scavenged for carrion. The oceans, too, were teeming with life. During the Mesozoic, marine ecosystems were incredibly diverse and productive. Coral reefs flourished, providing habitat for a wide range of marine organisms. The warm, shallow seas were home to a variety of invertebrates, fish, and marine reptiles. Ichthyosaurs, resembling dolphins, and plesiosaurs with their long necks and paddle-like limbs ruled the seas. These marine reptiles were highly adapted to life in the water, with streamlined bodies and powerful flippers that allowed them to move swiftly through the ocean. They were top predators in their environments, feeding on fish, squid, and other marine animals. The Mesozoic was a time of warm climates and high sea levels. The Earth's climate during this era was generally stable and warm, with little variation between the poles and the equator. This created ideal conditions for the proliferation of life, both on land and in the oceans. High sea levels led to the formation of shallow inland seas, which were rich in nutrients and supported diverse ecosystems. The continents, once joined as the supercontinent Pangaea, began to drift apart. This process of continental drift had a profound impact on the Earth's climate and the distribution of life. As the continents moved, they created new coastlines and ocean basins, which in turn influenced ocean currents and weather patterns. This dynamic environment drove the evolution and diversification of many species. This continental drift created new oceans and isolated land masses, driving further evolution and diversification of life. Isolated from one another, species on different land masses followed unique evolutionary paths, leading to the development of distinct flora and fauna. This geographic isolation was a key factor in the incredible diversity of life that characterized the Mesozoic era. However, the reign of the dinosaurs was not to last. Despite their dominance, dinosaurs were not immune to the forces of nature. The Mesozoic era was marked by several extinction events, but none were as devastating as the one that brought the era to a close. Another cataclysmic event, the Chicxulub impact, brought the Mesozoic to a close. Approximately 66 million years ago, a massive asteroid, estimated to be 6 miles wide, slammed into the Yucatan Peninsula in what is now Mexico. The impact released an unimaginable amount of energy, equivalent to billions of atomic bombs. An asteroid, estimated to be 6 miles wide, slammed into the Yucatan Peninsula, triggering widespread fires, tsunamis, and a global impact winter. The immediate aftermath of the impact was catastrophic. The intense heat generated by the collision ignited wildfires that raged across the continents. The impact also triggered massive tsunamis that swept across the oceans, devastating coastal areas. The dinosaurs, along with many other species, perished, marking the end of an era. The long-term effects of the impact were equally devastating. Dust and debris thrown into the atmosphere blocked out sunlight, leading to a dramatic drop in temperatures and a prolonged impact winter. This sudden and severe climate change disrupted ecosystems and food chains, leading to the extinction of approximately 75% of all species, including the non-avian dinosaurs. The end of the Mesozoic era marked a turning point in the history of life on Earth, paving the way for the rise of mammals and eventually humans.